Our next speaker is Jens Keutgen from Aachen. I'm just going to give you remote control, Jens.
Okay. Can everyone hear me?
I can hear you just fine.
Perfect.
Jens, I think you should be good to go.
Okay. Yeah, thanks for the invitation, and I'm really happy to talk about this. It's funny to talk now after this talk about the new features of AP Suite, as a lot of the stuff I'm talking here came from the fact that previously these custom analyses were not possible. So let's see. Yeah, it's working. So previously, IVUS was limited in a way that once you wanted to do something that was custom, not available from IVUS itself, you couldn't do it, or you needed to wait for it to be implemented, and it might never happen, or it takes a lot of time. And the alternative you had for this was using custom scripts, which for the most part were not really user-friendly, as the moment you share them, it's hard for other people to grasp what you're actually doing. So it can be tedious. But with the EPOS file, we could, in theory, get all the data that was collected in IVUS, that was generated in the reconstruction, as well as all the raw data, and get most of the analysis, all the analysis that we wanted to do. So for us, we went to work on MATLAB, as we use the software as a way of generating fast and also fairly complex analysis. It's not the fastest in terms of runtime, but it's really easy and fast to implement new features, as you have all these visualization options already available. So there you have quite an advantage. So in the end, we came up with the goal for our software EPOSA to create an easy to use and also easy expandable platform for expanded atom probe analysis. And the key part here was for us always to create something that's for expanded atom probe analysis, as we were interested in a lot of stuff that is happening to the multiplicity of ions, and this was all not available in IVUS, and we never tried to reproduce or redefine the features that IVUS was actually doing, but just look at the regions that IVUS couldn't handle as well, and try to provide a toolkit that's easy to use there for anybody who might be interested in this. And with this came out EPOSA, as you can see here, which based on the principles that it was fast to install and then easy to use. So you can just install it in MATLAB with a single click, and then load your range file and your EPOS file into the program, and then have a wide variety of data selection options where you can filter your data in terms of ion, in terms of detector position. You could filter in terms of reconstruction position. You can select the multiplicity that you want to use for your analysis, and also you can filter in terms of the voltage, the mass spectrum, and the nulls. So every way that is, every data stream that is input into this analysis is in the end filterable for every analysis that you want to do. This makes it for us then afterwards really easy to implement new ways of visualizing and analyzing your data, as this core principle is included once and all the rest is just built on top of this base, and then can be pushed out if something new is needed within the matter of hours sometimes, as MATLAB provided us with this, so we could easily adapt to new ways we wanted to look at our data, and this is all of course available for you. Then also there are nice ways of saving the results, and you can also directly then manipulate them, or not manipulate, but visualize them in MATLAB itself, and use the MATLAB features to work with the plots from there. So what options do we have now for data visualization? At the moment, we have options to visualize the reconstructions, not create one, but we can create isosurfaces, with the advantage here that we can create the isosurfaces also in terms of multiplicity, or all the parameters that you saw before. So showcase areas where the multiplicity is higher. You can basically select any value as your isosurface value. We can also visualize detector event histograms, and there's some functions for working with pores, and we can see the evaporation sequence, which ions were evaporated together, if there's some insight for you in this. This came then to our main focus, why we initially developed this, which was the multiplicity analysis, where we could just visualize the multiplicities for different ions and multiplicity in which they occur with which frequency. In addition to this, you could showcase the distance between multiple events on the detector as well in the reconstruction. We can visualize the multiplicity in 3 dimensions, seeing different changes there. There's an option to get correlation histograms out there. You can also filter these correlation histograms and select data part of it there. And we have an option for the co-evaporation analysis that enables you to see which ions evaporate correlated or anti-correlated. And with all this, we already worked a lot with the software over the past few years. Maybe some of you have heard me talking about this 2 years ago in the last AtomProbe workshop, or this workshop here. And we initially started with the quest for investigating crystallizing phase change materials, where we saw a really high multiplicity and attributed this to bonding mechanisms. And this was then further extended over the last following years, and even we found we had some nice samples where the multiplicity due to some nanoprecipitates really changed throughout the sample, and all the software that was previously mentioned really guides us in understanding all of this better. And now for a bit of a shift, this was the initial way why we developed this, and then later we had some other things that we needed to solve, which was for us peak solving of overlaps for proximity histograms, where especially at interfaces between 2 materials, the chances are really high that you have overlaps due to the large number of ions, and there there's no other, we didn't need to know another way to do this then, or to do this without anything that we didn't code. So we made our own stuff together with the work of Andrew, which used the natural abundances of the different ions in each bin of the proximity histogram in a maximum likelihood estimation and a maximum likelihood estimation to get some nice data out of the proxygram uncorrected. I could go on for this for quite a while, but as time is limited, I instead just want to show you some case studies that we performed on this. For one, here we have some copper, indium, gallium, selenide, zinc oxysulfide interfaces, which have many overlaps between zinc sulfur and also zinc oxysulfide with selenium, where when you just run these interfaces, investigate these interfaces, you see that the zinc concentration is underestimated while the sulfur concentration is overestimated. And even if you can correct this, you will still have the problems that your selenium will be overlapping with these peaks as well as on both sides of the interface. So here you can see on the top the before correction and on the bottom the below correction, which as we were able to correct this here quite nicely, could correct the zinc sulfur concentration, also the oxygen concentration, and limit all the inferences from all these different overlaps. A second case study was performed on a simulated data set, as you can see here, where we generated 2 nanometers big precipitates in many of them in a small cube, and then looked at our generated composition and the not corrected and corrected composition, where you can see here on the top again, that especially the aluminum content is highly overestimated. And if you looked on the dashed lines in the bottom, you can then see that the correction is actually working really well. And even though the errors due to this really limited number of ions get a little bit bigger, we still have really high resolution in terms of the proximity histogram itself. There's still a little bit of smearing, but this is mostly just due to the fact that the isosurfaces itself at precipitates that are this small are, as most of you probably know, not perfect and probably can't be 100% perfect, but the solution that we found here is already really nice. So with this coming to a conclusion, maybe for people who want to use these proximity histograms, you just load in your data files. Then you can see here on the right side of the screen that you can just generate your isosurface really quickly in a way by just selecting the data that you want to include. And then you just need to select the range file that includes every ion that's inside your mass spectra. And if an ion is ranged once, the software will find the missing peaks and then calculates the overlaps in this and gives you, with one simple click, the solved proximity histogram. But overall, we created this user-friendly and expandable, fast expandable tool set, which with APT Suite 6 might not be so needed, but for now was quite nice. That has in the key features these easy data selection options, and then a whole bunch of options for analyzing multiple events and also generating proximity histograms with solved overlaps. And if you're interested in all this, and would like to try it, just write me an email. This is most of this is developed by myself, and there might be some errors, so I like to stay in touch with people who are using it, that I can help them when they find something that's not working as intended. Yeah, thank you.
Okay, thank you, Jens. So I guess this sort of hinted at the end of your question there. So how do you think that users are supposed to interact with that? Are you going to be providing a link ultimately to the software, or is it just for now it's email? How's this going to work in the future?
So in the future, maybe I'll provide a link, but sometimes, especially as MATLAB versions for everyone who's using this sometimes change. I like to stay in touch with everyone who's working with it, but just write me an email. I will provide you the software itself. You can just install it in MATLAB then itself, and inside the software is something that I included that when it starts, it checks for a new version and automatically updates it. So even if we don't stay in touch, we'll always get the newest version. Besides this, I just like to know who's using it for the moment, and maybe I'll publish it, but I'm not sure yet.
Okay, so I guess another question. I mean, for people who aren't for other laboratories like the Stuttgart laboratories or other people who are building their own equipment, how would you see them interacting with this software?
If they want to interact, you just need the range file and the EPOS file. I saw for the people from Stuttgart that they can export EPOS files. So if they want to just export them, or if they just export their files, they can then quickly use them to import them into this software and use it. So
okay.
Yeah,
we've got another question about proxygrams. In terms of do you have enough statistics to use the natural abundance in each of the proxygrams?
Yeah, it depends, of course, on the interface you are looking at. We are currently on a way we submitted. So Andrew and I submitted a paper about this, where everything about this is discussed in more detail. But if you have a proxygram, it depends on how big your interface actually is. And you can, of course, then increase the number of ions that are included by just increasing the bin size. And depending on which interfaces, you might then lose a little bit of resolution, but probably most interfaces that occur in atom probe should be investigatable with this solution.
I think we've got time for one more question, just in the last minute. So I guess the question we've got is for people who can't generate EPOS files or don't have the capability, how might they go about interacting with your software directly if they don't have access to IVAS?
If they can't generate EPOS files, I think they just would need to contact me. I think it's quite quick to, once they have the data, to create a new script that just imports different file formats. Up to now, it wasn't really necessary, so there's nothing in there yet, but I'm happy to provide something for people who would need it.
Dan, were there other questions you'd been able?
There were. I'm just having a quick chat through them here. So we've had one, I think it was from Martin Meyer at Oxford regarding Jens. Jens, are you still on the line?
Yes, I'm still here.
Okay. with your code, is there a specific need for certain MATLAB versions to be able to support that? What versions of MATLAB going forwards are you supporting?
I'm not 100% sure, but it should be something like 2016 upwards, then there should be no big problem.
Okay, I think with that we can move on to our next section. Thank you very much, Jens. That's great.
You're welcome.